Hi everyone and welcome back to Maths and Physics with Mrs. Simons. Today's grade 12 trigonometry lesson. We're looking at video number 4 of 9. And yeah, these identities, we're specifically looking at how we expand and reduce while given double angles to solve the identity, right? I say I can do many examples of the same thing, but I'm just showing you the variations so that when you practice for exam, you've practiced all of them, not the same thing over and over, and then you end up being caught out with a variation. Right, problem number 1. Right, given to us, we have cos 4 alpha equal 1 minus 8 sine squared alpha plus 8 sine to the power 4 alpha. Right, so I have to take the left hand side and make it like the right hand side. So the only thing I can do with 4 alpha currently is make it a double angle, right? So if I make it a double angle, I must introduce the value 2. So that becomes cos 2 times 2 alpha, right? 2 times 2 would give me 4 alpha. Right? Now, because the right-hand side, as you can see, there's no cos there. It has only sine squared, sine to the power 4. So when I expand this cos 2 times 2 alpha, I'm going to expand it using the cos double angle that only has sine in it, right? So cos 2a, we should know, is 1 minus 2 sine squared a. It's on your formula sheet, end of the year and prelims. So therefore cos 2 times 2 alpha becomes 1 minus 2 sine squared 2 alpha. Now I have sine and I have 2 alpha. 2 times alpha means I have a double angle for sine. So I'm just taking the square out so that I can expand the double angle. So 1 minus 2 sine 2 alpha squared. Now sine 2 alpha is the easy one. It can only be expanded and become 2 sine alpha cos alpha. Right, but I'm squaring, so 2 times 2 gives me 4. Sine times sine gives me sine squared. And cos times cos gives me cos squared alpha. Again, you see my problem here. There's a cos squared. That answer is no cos squared. So now, going to your grade 11 work, square identity that says cos squared alpha is the same as 1 minus sine squared alpha. So if I multiply out here, 2 times 4 simply gives me 8 sine squared alpha cos squared alpha. But now we're changing cos squared alpha to 1 minus sine squared alpha according to the square identity. And then we're just testing, can you find the product? So 1 minus 8 sine squared times 1 stays minus 8 sine squared. Negative times negative becomes positive. 8 times 1 stays 8, and sine squared times sine squared becomes sine to the power 4. So now this looks exactly like my right hand side, and therefore I've proven this identity. Right, I hope you follow, I hope it makes sense. Let's go to problem number 2. Prove the following. So now I've just used cos 4 alpha, and then there we're using sine 4 alpha. Equal 4 sine alpha cos alpha minus 8 sine cubed alpha cos alpha. So again, the only thing I can do with 4 alpha is I can make it a double angle. So you should know 4 alpha is 2 times 2 alpha. So that becomes sine 2 times 2 alpha, and if I expand it will become 2 sine cos, right? So that there becomes 2 sine 2 alpha cos 2 alpha based on how we expand the sine double angle. Right, so from there we should know cos 2 alpha can be written as 2 cos squared minus 1, 1 minus 2 sine squared, or cos squared minus sine squared. Yeah, cos 2 alpha will be written as 1 minus 2 sine squared. So now I have 2 sine 2 alpha. If I expand it, becomes 2 sine alpha cos alpha. So I still have my sine and cos. But then the cos 2 alpha would become 1 minus 2 sine squared. Reason why I've done that, they've got the sine cubed. And I only have a sine alpha. So the only way to go from sine alpha to sine cubed, I have to multiply it by a square. So that is the hint I used why I changed cos 2 alpha to 1 minus 2 sine squared alpha and not the other 2. Right, so if I multiply 2 times 2 would give me 4 sine alpha cos alpha times 1 minus 2 sine squared alpha. So 4 times 1 stays 4. Sine alpha cos alpha. 4 times 2 becomes 8. Negative times positive stays negative. And sine alpha times sine squared alpha becomes sine cubed alpha cos alpha. This now is exactly the same answer I have on the right hand side, and it equals my right hand side. Right, so as you can see in these problems, we're just testing can you create double angles, and from there you have to select. And the key thing is for cos 2 alpha. You have to select the right formula to ensure that you're going to get to the answer on the right hand side. I hope it makes sense. Wish you nothing but the best. God bless. Bye.